I'm recording. Okay. So yeah, actually that's a good idea. So you know what? Um, one of us can do the Riemann sums and one of us can do um integral rules, and then we can split up into groups that way. Does that sound good?
Yeah, sure.
Okay. Which one do you want to do?
I honestly don't care. Either way, I can do the integral stuff.
Okay, I'll do Riemann sums then.
Cool.
Okay.
So
So
who's
put in chat who wants to do integral rules with Mr. C, and then if you want to do Riemann sums, um, just say that you want to go with Mr. Bay. So I need Atani, Sean, Sergio. Okay, so Atani with Mr. C. Sergio also with Mr. C. Alfonso, Sean. I know you're kind of just listening, Alfonso. Um, okay, Sean will go with me. Okay, I'm gonna put you, Alfonso, with Mr. C. You can message Mr. C if you want to go with me. Okay.
You'll
So
be recording your thing, right, Mr. Bay?
yes.
Okay.
trying to get them both?
Okay. I'm not great at breakout rooms so far.
Hi, Trayvon.
Hey Trayvon. We are going to be going over two different subjects today, and you can choose which one you want to go to. You can either choose um, integral rules with Mr. C, or you can choose Riemann sums. I'm going to be going over LRAM, RRAM, MRAM, trapezoid with me. So you can choose either one. So let me know, would you rather do Riemann or integral rules? Do you it does it not matter to you, or can I get like some sort of, you gonna stay with me? Okay, I'm gonna put you then in room 2. Sorry about that, you guys. I'm not used to doing breakout rooms. Okay, I'm gonna start sharing. Okay, so how do you both feel about Riemann sums? I'll just start doing an example. Need a lot of help? Okay. So let's say we have some sort of curve that we want to find the area under, right? This curve can be whatever, a random curve, right? And we want to find the area from A to B. A way we can find the area under this curve is by drawing rectangles, right? And we use these rectangles to approximate the area under the curve. And using these rectangles aren't exact because the format's a bit weird, but using these rectangles, you can get some approximation of the area. And this is what Riemann sums is. So if you look, there's some oh no, I don't want to do that. If you look, it's not a perfect approximation, right? You know, there's all this area that's either overestimate or underestimate, right? But for the most part, if you use enough rectangles, it'll get you a good approximation. Are you both following me so far? Okay, so let's say we take this function here, right? We have 5 intervals. I'm trying to think. Let's say we start at, let's say a is 1 equals 1, and then 1, 2, 3, 4, 5, 6, and b is equal to 5 or equal to 6, right? And we want to use 5 rectangles to approximate this area under the curve. Okay. If we're using 5 rectangles to go from a equals 1 to b equals 6, what is the width of every rectangle? So if we're going from a is equal to 1 and b is equal to 6, right? We're going from 1 to 6 as an example. Great. The width of each rectangle is going to be 1. 1, 1, 1, 1, right? Because this will be 2, 3, 4, 5, right? So now all we need is the height of each rectangle. Okay, and that's how we're going to find the area of each rectangle, because area of rectangle equals base times height, right? Or b times h. And so we already know the base of each rectangle is 1, right? So now we just need the height of every rectangle. And I'm just going to put in numbers, right? So let's say like f of 1, we'll call that 3. F of 2, we'll call that 2. I'm just putting in random numbers. And we're going to do a problem with these. F of 3 equals 4. I'll move it up so you can see it. I'm just putting in numbers at the moment.
Hey, Mr. Bay, can you move David into this breakout group?
Sure. Okay, hold on, let me get. Okay. So Trayvon and Sean, I just made a bunch of points, right? So f of 1, f of 1 is 3. So this point is 1, 3 here on the curve. This point over here is 2, 2. Are you following me so far? Yep. Okay, cool. So now now that we know the height of each rectangle, which they will give you. For Riemann sums, they will give you the height of each rectangle. It's just up to you to figure out how to get there, right? So if we wanted to use LRAM, we'd take the leftmost point of the rectangle. So we'd take the leftmost point. And so the leftmost point of the first rectangle is f of 1 is equal to 3. And then the leftmost point of the second rectangle is it would be here, f of 2 is equal to 2. What is the leftmost point of this rectangle, the third rectangle? Trayvon, do you agree with Sean? Or you're not sure? You do agree? Okay. So now we just need to find the area. I'm going to erase some things. We just need to find the area of all the rectangles now, right? So if we know the area of each rectangle is b times h, well, we know base is always 1, and then the first height of the first rectangle at the leftmost point is 3. And this is what's known as LRAM. We're taking the rectangle at the leftmost point. And so 1 times 3, and then the base of the second rectangle is still 1. And then the leftmost point of the second rectangle is 2. And then we go to the third one, right? Base is still 1, and we already know that the leftmost point height of the third rectangle is 4. What's the fourth rectangle going to be? Great. 1 times 3.5. And then the last rectangle? Well, actually, is it the last rectangle? Do we do a 1 times 6? No? Do you agree, Trayvon? Do we do a 1 times 6? There's no rectangle there, right? Perfect. You understand that if you took the leftmost height of the last rectangle, it's actually that 3. But then when you get up to 6, there's no more rectangles because we're only going from 1 to 6. So perfect. Great job. With LRAM, we already are getting this rectangle because we took this point. So good job. And so from there, it's pretty much done. You get LRAM equals 3 plus 2 plus 4 plus 3.5 plus 3. David, I know you kind of came in a little late, so let me know if things are a bit confusing at the moment. And then I don't know what the math is. 9, 12. And LRAM equals 15.5. At least I think, if my math isn't wrong. Okay, no problem. Okay, so that's all it takes for LRAM. You just have to find out the height of each rectangle, of each point, and make rectangles from those points. And from there, most of the time, it's the same width each time. Can I get a 1 through 3, Trayvon and Sean? Okay, great. So now we're going to do RRAM. And so now we're making different rectangles. Okay. Now we're doing it from the rightmost point. So now our rectangles are different. We're going to end up getting different rectangles. Do you see how I'm going to the rightmost point and then drawing my rectangle? So we have the same curve, but we're drawing the rectangles from the rightmost point. Okay, because we're doing RRAM now. There's two different ways you can do this. You can start from the rightmost. A lot of people like to start from the rightmost rectangle, right? Because if we do that, we can start at the very bottom here with f of 6 equals 6, and then go the second rectangle, third rectangle, 1, 2, 3, 4, and 5. And once you get to the 5 rectangles, you know that you're not supposed to do this one because there's no rectangle over here. There's no rectangle over here. You've already I can't erase this arrow. Okay. But what you could do is you could still start from the left. You just have to recognize that you're not using this for RRAM. You're not using the very first point because the rectangle would be outside the bounds. There's no rectangle over here because that's what this point represents if we're using the rightmost of each rectangle. Does that make sense, David? Okay, no problem. Let's start from the rightmost point. Okay, so what we did previous was we did LRAM, which meant that we made rectangles from the left using the leftmost point. So if so we would take rectangles from the leftmost point, and this would be the rectangle if you're taking it from the leftmost point, right? That would be the first one. The second one, the second rectangle from the leftmost point would be here, because we're taking the rectangle from the leftmost corner from the curve. But because we're doing the rectangles from the rightmost point, you actually go to the right portion of the curve, and you can make this rectangle here. I'm sorry, people texting me. I'll silence my phone. Does that make a little bit more sense, David? So for left, we start, everything's about the curve. We're trying to get the area under the curve. So we have 6 points. We have 1, we have 2, 3, 4, 5, and 6, right? And so we are trying to make rectangles from these points. And so if we start with the leftmost point and make a rectangle, we would get this. That would be our rectangle, except much more nicely drawn. But because we're starting from the rightmost point for each rectangle, we get this, which is a rectangle that's drawn. And that's where we get RRAM. Yep. Basically. Yeah, so if you start from the opposite end, this is what you'll get. You'll get this rectangle here, which is drawn. And so as we already went over, the area of each rectangle. Yep. Yeah, so this rectangle would be bigger because this left point is higher than this right point. But this left point is lower than this one, so this rectangle would be smaller. But so now we're just starting from the right. So let's start from the right. If we were to start from this rectangle, what is the height of this rectangle? Remember, the width of each rectangle, as we've determined, is 1 because it's going from 1 to 2 to 3 to 4 to 5 to 6. So RRAM equals 1 times, what's the height of the rightmost rectangle? It is 6. Yep. The points are to the right of where I'm writing. And so let's get the second rectangle. What's the height of the second rectangle? So we know that f of 6 is 6, right? Based on these points, right? Because this is our 6. And so this point is 6, 6. And yeah, this point, because f of 5 is 3, so at 5, we get 3. So we get 5, 3. Make sense? Trayvon, Sean, you still with me? Okay, perfect. So let's just go through this a bit quickly now. David, do you see how the width of each rectangle is 1? Yep. Okay. Good, 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 good. So the second rectangle has a height of 3. What's the third rectangle? Great, good job. Good job. Oh, everyone got that one. Nice. Okay. What's the fourth rectangle? Okay. Fifth rectangle. And sixth rectangle. Great job, Sean. Yep. What Sean's saying is correct. There's no sixth rectangle. Because if we were to take f of 1 is equal to 3 and go right, it would actually be outside our bounds. So we have to remember to stop at the last one. Because as you're saying, if we take the fifth rectangle, which is f of 2 is equal to 2, and we go here, we get our last rectangle, and we don't need the last point. So that's why it's crossed out. Okay. And so from there, the math is pretty simple from this point. To get your RRAM, so you get 6 plus 3 plus 3.5 plus 4 plus 2. And that is what? I think 18 and a half. Yep, 18 and a half. And that's your answer. Note for our LRAM was, I think our LRAM was 15 and a half. So it's just funny how for the same curve, we can get different area approximations. And I just made up this function. So this function might, who knows what the actual area under this function is. I just made up points. So now the third one we're going to be doing, we're going to go from, it's called MRAM. So we're not going to have to find the midpoints. I didn't give you the midpoint, so here's what we're going to do. I'm going to erase these again. What we're going to do is instead, we're going to go from 1 to 5 instead. Okay, that way we have a middle point. So we no longer have this. I'm going to actually write this out again. That's not what I meant to do. Let me know if the red is too much for you guys. I mean, I can change the text color. Typing's hard today. Did you guys have a good St. Patrick's Day? Pretty, you know, good considering pandemic. Okay, so now, you guys do anything for St. Patrick's Day? Have a nice dinner or anything? Green's my favorite color, so I've got some green on. Oh, where are you finding Courts of the Rims, Trayvon? Like, normally the places I go to play basketball, all the rims are taken down. Are they back up? Down the street from Hawkins? Interesting. Okay. The parks I've gone to, they've taken the rims down, and I'm like, I'm terrible at basketball, but I love playing, so I'll have to check that out. My friends don't play basketball much, so that's probably why I haven't like played too much. Okay, cool. So now what we're going to do is we're going to do MRAM. And if MRAM is or if LRAM's the left point and then RRAM's the right point, what is MRAM? What do you think MRAM means? Middle point, perfect. So we're going to go from 1 to 5 with 2 rectangles. And don't worry, Miss Rose will always give you, you don't have to find the midpoints. Miss Rose will make sure that the midpoints are available for you. If not, she will have the function and you have to plug it into the function to find the midpoints, but you will always have a way to figure out the midpoints. Okay, so don't panic over that. So if we want 2 rectangles, let's say the first rectangle, what's the width of each rectangle going to be? If we're going from 1 to 5 with 2 rectangles. Do we agree with Sean? Okay. It would be 2. Okay, let's go from 1 to 3 then. What is the midpoint of 1 to 3? Yep, it would be 2. So we need a rectangle that goes to 2. You see how it goes through this midpoint? And that's what's the midpoint of the rectangle that goes from 3 to 5? So what is f of 4? 3.5, right? And of course my drawing skills aren't great, but it kind of goes through that midpoint. Okay, so now area of a rectangle, right? What is the first rectangle? Remember, we have a different width now. Yeah, 2 times 2? Do we agree with David? Actually on both? Do we agree with David on both? Two times 2? Yep. So our width is now 2. The width of each rectangle is 2. And then the height is the midpoint, and the midpoint's f of 2, which is 2. And then the second rectangle is what David said, where the midpoint is at f equals 4, and f of 4 is 3.5. So 2 times 3.5. It's not too bad. All we're doing is, the main thing with LRAM, MRAM, RRAM is as soon as you get your points, just draw it out. If you draw it out, like just like sketch it out, you will have like a much easier time. Like, okay, I've got to do this rectangle, this rectangle, this rectangle, this rectangle. It'll be a lot easier. The hardest part might be if she asks you to if she asks you to if she gives you the function and you have to plug in for each point. So she might give you like x to the third or something like that, and you might have to say, okay, well, I need to go from 0 to 3. I have to plug in 1 to x to the third, into x to the third, and I have to plug in 2 for x to the third. I have to plug in, and you have to manually get your heights. But don't worry, as long as you like plug in all your values and get all the heights. If you have all the heights, then the rest becomes simple. You just have to recognize like what the width is of each rectangle and then plug in for the heights. And if you draw it out, you won't mess up. We have any questions so far? David, Trayvon, Sean? Okay, we're going to go to the last one, which is the hardest. So we saw some wildly different answers so far between LRAM, MRAM, and RRAM, right? To be fair, we got rid of a point for MRAM, so that doesn't count. But we saw completely different answers for LRAM, RRAM, because it's not super accurate if you don't have a ton of rectangles. But what you could do to make it a lot more accurate is something called trap. Which means trapezoid, basically. We are estimating using trapezoids instead of rectangles. Okay? So we're going to do, again, 1 to 5 with 4 trapezoids. Okay? Does anyone know the area of a trapezoid? And put no, like most people don't know the area of a trapezoid, so it's completely fine to put no. You don't remember the area of a trapezoid. You're right, it does have something to do with 1/2. Okay, so I'm gonna help you remember how to remember area of a trapezoid. So let's just let me do some drawings real quick. Area of a rectangle, right? Not too bad, because you have base times height, right? But what if you had a trapezoid has the same base? Oh, jeez. I'm gonna try and draw a trapezoid with the same base. That's gonna be as good as I get. We now have a trapezoid. It has the same base, but it has 2 different heights. It has a height 1 and a height 2. We can calculate it still with base times height. Still equal to base times height. The problem is we don't have one height. So instead, what we have to do is we realize that the area of a trapezoid is going to be equal to the base, but the height is going to be the average of height 1 plus height 2. Actually, let me make this simple. As simple as I can. Because we don't have one height, we have to take the average of the 2 heights. And when you take the average of the 2 heights, we make it, in essence, become a rectangle. So let me just draw another one. So we almost convert it into a rectangle of base and then h1 plus h2. Oh, over 2. By adding the 2 heights, and then you have to divide it by 2. If you want to take the average of 8 and 2, what's the average between 8 and 2? can you give me an answer of like what's the middle number? What is the average between 8 and 2? Can you? Do we agree with David? So let's just go to a number line, right? Got 2, 3, 4, 5, 6, 7, 8. It turns out the average is actually 5 because it's 3 away. 1, 2, 3 from 8, and then 3 away from 2. 1, 2, 3. And we can find, I'm not sure if you guys have seen this, but if you want to average two numbers, average of A and B, it's all good, equals A plus B over 2. Let me just, oh, I accidentally, have you guys ever seen this before? Yeah, like average equation. If you want to find the midpoint between two numbers, you take A plus B. So if we do this for 8 and 2, right, we want to find, okay, no problem. So this will be good in life in general, too. If we want to take the average of 8 and 2, we can add them. Take 8 plus 2 all over 2. And we get 10 over 2, which is equal to 5. Are you following me on average? So let's take, I'm just going to do another average one. Let's take the average of 49 and 74. And I don't even know what that average is, right? So we'll take 40 average equals the two numbers 49 plus 74, and then all over 2. And you'll end up getting the midpoint between the two. Does someone want to tell me what that number is? Put it into our calculator. When I put it into mine, I get 61.5. And so most people won't be able to just look on the number line and like try and find the very midpoint, but 61.5 is 12.5 away from 49 and 12.5 away from 74. We found the exact midpoint between the two. We found the average. And you're going to have to do that for a lot of different things in life. So this is just a good equation to remember in general. So going back to this trapezoid, we wanted to find the average between height 1 and height 2, and we convert it into a rectangle of height 1 plus height 2 is equal to 2, or over 2 is equal to our new height. Okay, so I'm going to erase this. Okay, so area of a trapezoid, if we times base times height, it's still going to be base, and it's going to be times the height. And our height is 1/2 times our height 1 plus our height 2. And remember, multiplying by 1/2 is the same thing as dividing by 2. So if you want, you can rewrite it like this. It's the same thing. I can take out an extra parentheses if you want. Can I get a 1 through 3 in chat from all of you? Because this is hard to remember. So 2.5. Okay. Yep. So it's the same thing as a rectangle, right? It's base times height. We have the same base as the original rectangle, but because it's a trapezoid, we have 2 different heights. And so we have to get an average height to find the area. There's a whole proof to like finding the trapezoid, but I just don't have time to do that at the moment. But that can help you remember what the area of a trapezoid is. It's still base times height. You just have to find the average of the 2 heights, and then multiply that to the base. So doing that, we're going to now do the 4 trapezoids. Okay. So our first trapezoid is this. So what's the base for each trapezoid? Our base shouldn't be changing. Base of each trapezoid is 1. We have 4 trapezoids going from 1 to 5. Okay, so now we just have to figure out the height of each trapezoid, right? So we're going to start with and yeah, we're not doing trap music, but you can play trap music while you do this if you want. So again, we have 1, so that's our base, and then what are our 2 heights for this first trapezoid? Do we agree with Sean? Our 2 heights are 3 and 2. So we have to add 3 and 2 and divide by 2. Okay, so that's our first trapezoid. Now we go to our second one. Again, the base is 1. What are our 2 heights now? Okay. Trayvon, Sean, do you agree with David? What about you, Trayvon? Okay, great. Our next 2 heights. And then the third trapezoid. What's our width again for each trapezoid? 1, okay. Now we have to do our next 2 heights. Yep, 4 plus. You guys are killing it. And then our fourth trapezoid. Base is 1 again. And then our 2 heights. Great. Okay, so this is a bit more complicated math, but okay, so our first trapezoid is 3 plus 2 over 2, so we get 5 over 2. Our second one is 2 plus 4 over 2, which is 6 over 2. I know I can simplify that, but I'm just going to do it a long ways first. 4 plus 3.5 is 7.5 over 2. And then 3.5 plus 3 over 2 is 6.5 over 2. So 5 plus 6 is 11, plus 7.5, 18.5, and then 6 plus 6.5 is, what, that's 25 over 2? Is that right? And so that's how you get trapezoids. Can I get a 1 through 3 in chat from all three of you? The final is just 25 over 2. You can keep it in fraction form. Okay, before you guys go, I'm just going to show you one real quick thing. She might not give you this outright, okay? It's a lot easier if we have the points, right? But what she might do is, I'm going to actually erase all this. She might not give you all of this, and you have to draw it yourself, right? So I don't want you to get confused on the test when that happens. What she might do is she might just give you f of x equals x squared, right? Find LRAM, RRAM, MRAM, trap for area under curve from 0 to 4. Okay? The first thing you do here, you can draw it. I always think we should draw it. But the first thing we do is we need to find our points, right? We need to create this. This is like the first thing we need to do. And since we're going from f of 0 to f of 4, what's our f of 0? 0, f of 1, 1, f of 2, 4, f of 3, okay, f of 4. Okay, now that we have this, everything's the same. So we had to do this manually, right? And that's why I want you to make sure you guys didn't freak out if you didn't get this table, right? If she just gives you a function, it's okay. You can make the points manually. Once you have this, it becomes a lot easier. And then from there, I encourage you to draw it. X squared is this, right? And then you can draw your little rectangles, you know. You can draw your rectangles from there and make sure you don't skip one. Right? That can be your 4 rectangles. Okay? And the purpose of drawing those rectangles is to make sure that you don't accidentally add another rectangle. You know, you maybe, if you do LRAM, you might accidentally do a rectangle where the last point here, which you're not supposed to do for LRAM. The last one, you don't. And then if you're RRAM, right, you don't do this point because it'll go past it. But yeah, I just wanted to make sure that just get the points first. Okay. It is 2:33. I kind of went over, but so you guys are free to go. I think I'm going to close the breakout rooms now. So we good to go? Okay. Well, thank you, David and Trayvon, Sean, for participating, because, you know, I wouldn't be doing this if I didn't want to help you guys out, and I wouldn't be doing this if you weren't participating. So I feel validated that you are appreciating this. So thank you so much. Okay, I'm going to close the breakout rooms. Hello, Miss Rose. We're done. I'm sorry, I always take a long time, but
How'd it go?
Williams
went
and
pretty well.
Okay.
Garibay.
Should I stop
They can
recording?
do those things.
Yeah,
share it with
Atani
Eli
wanted,
on
hold on real
Monday.
quick.